let's go ahead and take a look at this forward. We're asked to solve this with substitution. That's what we were doing yesterday. So what can we do here? How can I solve this with our substitution? What do we need to do? Yeah. I know that y is going to equal this thing. So we can take this and do substitution. I want to take this piece and put it in place of this y. For some reason, when we get our two y equals equations and we're looking at substitution, we get a little thrown off. So I just wanted us to kind of see this. Because we're just going to set this up as our x plus 3 equals that minus 2x minus 9. We're still substituting it in place of that y. It's just that it's on the other side of the equal sign. It's still substitution. We're just setting them equal to each other. So then when we try and solve this, what do we need to do? A couple of options on how to approach this. What do you want to do? Get our x's together. How? Add 2x. Beautiful choice. Add 2x. That's going to give us 3x plus 3 equals negative 9. Then what do we do? Minus 3 on both sides. Minus 3, minus 3. And we get that our 3x equals minus 9 minus 3. Oop, not quite. As I owe you $9, then I borrow $3 more. I now owe you more money. So if I borrowed $9 and I borrowed $3, I now owe you $12 altogether. Be super careful. Those negative numbers throw us off every time. But then we're ready to figure out what our x is. We're going to need to divide both of these by 3. What is our x going to be? Close? Not positive 4. Negative 4. Negative 12 divided by positive 3 is going to be negative 4. But that's not my whole answer. That is almost half of my answer. I also need to know the y, and then we got to write it as a point. I have a couple of options for how to find my y. I have two y equals equations. I can use whichever one I want. I'm going to pick the easy one. I mean, you can do the bottom one if you want to, but I'm going to pick the one that just has adding, because why make it harder? So I'm going to take this equation here, where we know our y is the same thing as our x plus 3, but now I know what my x is going to be. My x is that negative 4. We're substituting it in. Plus 3. What is negative 4 plus 3? I owe you $4 and I pay you $3. Negative 1. I still owe you $1. If I owe you $4 and I pay you $3, I still owe you $1. So our answer here, our solution to this system, is the point negative 4. That's my x, and then my y, negative 1. So this is our solution right here. Okay. Questions on this? Okay. So we're going to finish out page 12 real quick because I want us to get a chance to practice with these story problems before we get into our other option for solving systems. So at the very, very bottom of page 12 has this story problem that we're going to talk through before we look at page 13. Mostly because I want us to practice it. And a lot of times in the story problems, especially the ones on the homeworks, the equations are just like kind of written in there and we're just looking at context. Sometimes we have to come up with the equations ourselves. And this one does not have an equation written in here for us. We have to find them ourselves. So we've got here our story that Angela and Jasmine are paying off their credit card debt. Angela's starting with $120 in debt and is going to pay $1 each day, every day. And Jasmine is starting out with $150 in debt and plans to pay off $2 every day. We're supposed to figure out on what day they will have the same amount of debt. What day will it match? Someone asked me for a pass. Did I write it? Genuinely don't remember. Okay. So we are going to look at Angela and Jasmine. I've got two people here. I'm going to write an equation for each person. So let's look at Angela. Angela is $120 in debt and is going to pay $1 every day. How can I write that as an equation? I know we have that Angela is, so I'm just going to write it like this. Her amount of money is A equals. How can I say that she's $120 in debt? Negative 120. She owes $120. How could I put into my equation that she's going to pay $1 each day? Every day she's going to pay $1 over 1x. And we're going to plus 1x. So she's starting owing money, and it's just going to grow and grow and grow and grow and grow. So it's going to increase, 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 get better and better. So this, of the highlighted pieces I have, is just basically straight up translation. Angela is. $120 in debt, owes $120. $1 each day, every day, per day. Each, every, and per are clue words that is probably your slope. Not guaranteed. Sometimes they give us extra information, but it's a really high probability. It's a good chance that if it says each, every, or per, that's going to be your slope. So let's see if we can put the same kind of equation together for Jasmine. We know that Jasmine is $150 in debt and is going to pay $2 every day. So how can I write an equation for Jasmine? She's $150 in debt, so negative 150 plus our 2x, $2 each day. And I'm just going to call that J is. Jasmine is. J equals. So if we ever have like a total or somebody is, those are going to be your equals. So what they're asking us, we're not just being asked to write the equations, we're asked to figure out when will they owe the same amount of money. When will Angela's debt be the exact same as Jasmine's debt? Oh, looky there. We have an A equals equation that I could substitute in. And I have a J equals equation, which I just need to make my purple a little bit purpler. I have a J equals equation. So we can substitute these in. I can substitute more than one time. I'm going to change my view just a little bit so I'm not writing at the very, very bottom. I'm going to substitute those two pieces in so I can try and figure out where Angela and Jasmine have the same amount of debt. So I know that Angela is at minus 120 plus 1x. You don't have to put the 1, but you can. And we know that's going to equal Jasmine at that negative 150 plus 2x. So I've substituted this one in for A, and I substituted this one in for J. I can substitute them both in here. I want to know when they equal each other. So what could we do to solve this? What would we need to do here? Get our x's together. I was going to say, and 100% we'll be doing that as well. Yep. So if I want to get my x's together, I'm going to minus x from this side. If you always move the smaller x, you will wind up with the least amount of negatives. Doesn't really matter. We can deal with negative numbers totally fine. But if you don't like negatives, that's a way to keep that from happening. So then we have our negative 120 equals negative 150. 2x minus x gives us just a plus 1x. I want to get my x by itself. and I heard it on the first chance, is that we need to add our 150 to both sides to be able to get my x by itself. If I add 150 to both sides, this guy and this guy cancel out. That's the whole point. So we get just our x. And our negative 120 plus 150 is going to give us a 30. So on what day are they going to owe the same amount of money? The 30th day. Because remember that this one was $2 each day, and this one was $1 each day. So that X is standing for days. So 1 day 30. So if they start this payment plan and they pay it off, they're both going to owe the same amount of money when they get to 30 days. Go. We can do that. They don't ask us how much money they owe. I could figure out the Y and figure out how much they'd owe on day 30, but we don't have to. All we're asked is on what day. So that's our answer for this one. On 30 days, they're going to owe the same amount of money. So sometimes in these stories, we just have to find our pieces and basically run it through math translation. And sometimes we need to find our full ordered pair. Sometimes we don't. In the stories, we might not have to find both pieces. When we just are given equations, we have to find both pieces. Okay. Questions on this one? Because we are going to change veins and look at some different kinds of equations. Because this works super duper great when we have an x equals, or when we have a y equals. Or we can easily get to an x equals or a y equals without it going into fraction palooza. But that doesn't always work well. So when we have equations that don't switch into an x equals or a y equals very well, we have another method we can use to solve it. That's not graphing and that's not substitution. It is called elimination. And on top of page 12, you have this list. It's got a whole bunch of steps for you to follow that kind of works like a checklist. It's going to feel a little bit like Greek right now. Because what we're going to do is we're going to take our two equations, and instead of substituting one inside the other equation, we're going to take them together and go smash and smush them together. We're going to add them together, old school, like in columns. And the whole point of that is to get one of our variables to eliminate out. So when we're working with elimination, we're going to need to have the same number with the opposite sign on one variable. And I'm going to show you what I mean by that. You have two examples down here at the bottom. I'm going to show it to you on the first one, and then we will do the full work on the second one, mostly because this first one actually is not pleasant. So just 1 second, because I'm doing an adjustment on this. But we can see the first step on this first one. But we're not going to do the full solve on this. So here's our first equations that we have here. What we're looking for when we're trying to do elimination is we need one of our letters to have the same number but with the opposite sign. So here are my two equations. I have 4x plus 7y equals 20. And I've got 5x minus 7y equals 8. 4x and 5x, they don't match. Well, not too nice. But if I look at my 7y and my minus 7y, they have the same number with the opposite sign. So what we're going to do here is we're going to add this together very, very kind of third grade style is what it feels like. Where I'm going to put a plus, I'm going to put a big old line, and we're going to work in columns. So I'm going to say 4x plus 5x. What is 4x plus 5x? 9x. What is 7y plus negative 7y? This middle column. 0. I have 7y and negative 7y. I have 0 y's left. I have 7 yams. I give away 7 yams. I am left with no yams. And it's going to equal 20 plus 8, which is 28. Well, we don't typically write something down when it has a 0 times it, because 0 times y, it's the same thing as 0. So this is going to be the exact same thing as if we got 9x equals 28. So that's why it's called elimination. By adding these two equations together, my y's disappeared. They're gone. For now. We could finish solving this. The way this one is written, we're going to wind up with fraction-a-palooza, and so we're not going to finish solving this one. We will do the next one all the way to the end, but this lets us practice that addition part, because that's new and weird and awkward. But we're not going to finish solving this one because, ew, fraction-y. And we're not starting with fractions. Gross. So we will finish out this next one all the way to get an answer. That first one, we're just practicing the adding part, because ew. This one's very much the same way. Here we have minus 3x minus y equals 22. And our positive 3x minus 3y equals 18. So this time I've got a minus 3x and a plus 3x. They have the same number, opposite sign. It doesn't matter whether we do this with x's or with y's. We can use either letter that we want. But since they're already matchy-matchy on my x's, I'm going to go with that. Because I can add these together in our column, where I'm going to take my minus 3x plus 3x. If I have 3 xylophones and I give away 3 xylophones, I am left with 0 xylophones. You don't have to put the 0x here. If you can keep track of the fact that, yeah, that eliminated out, great. I'm just going to write it down here because it's easy, like it's helpful for some people. Then we have our minus y minus 3y. Look at this middle column. I owe you a yak, and then I owe you 3 more yaks, or yams. So we get a minus, I don't know why I switched to blue here, minus 4y equals, and then we're going to do our 22 plus our 18. That's going to give us 40. It's really important when we're looking at these kinds of elimination style systems that we do this only when we have our x's and y's on the same side and our equal signs are lined up. Can't go mixy-matchy on those pieces. But this is the exact same thing with these 0x's being here. They're gone. They eliminate out. And we get our minus 4y equals 40. What is y going to equal? How can I get y by itself here? Divide by the negative 4. We're going to get this one all the way down to a solution. Divide by negative 4. Divide by negative 4. So what will our y equal? What is 40 divided by negative 4? Negative 10. So my y equals negative 10. Awesome. When we write our solutions, though, we want to write it as an ordered pair. So that is the chonkiest of pens. Holy cow. Change that. There we go. We like to write this as an ordered pair, and right now all I know is that my y is negative 10. I don't know my x yet. So we've got to find that. We're going to have to figure that out by solving, and so we can substitute our 10 into either of our equations up here. It genuinely does not matter. We're going to pick one and substitute it in. I'm going to, for absolutely no reason, pick the bottom one. Just because I like positive 3 better. That is not the pen I want. So we're going to do 3x minus our 3 times that y. But now we know our y is negative 10, so I'm going to substitute that in. Equals our 18. And we're going to solve this to figure out what our x is. Well, I can do some simplifying here. I can multiply out my minus 3 and my minus 10. We can get our 3x. Negative 3 times negative 10 gives us plus 30 equals 18. I could get my x's by themselves. I could subtract 30 from both sides. What what do we get when we subtract 30 from 18? We get 3x equals what? Negative 12. And then to get our x by itself, we're going to divide by 3. So what is negative 12 divided by 3? Negative 4. So my x is negative 4. So my answer here is the point negative 4 tenths. So the adding together of our equations really is to make one letter cancel out. It should disappear. The substituting back in is going to be a little bit longer on these because usually there's a couple more steps. But this should always kind of make something cancel out. If we add these together and we don't lose a letter, stop right here. We should always lose one of our letters as we go through it. Sometimes it'll be set up really nicely for us, like this one, how we had our -3 and our +3. Or on this one where we just kind of saw our addition part and we had our +7 and our -7. Sometimes they're going to be set up really nice for our elimination right away. Sometimes they're not. Sometimes we're given equations that do not eliminate out nicely. And these are just really close together for no reason. I'm not a super big fan of the way I formatted this, but no, it's a vibe. So if we look at this bottom one here, it's really not set up nicely for elimination. But it's also really not set up nicely for substitution either. So if it's not set up nicely for substitution, and it's not super set up nicely for elimination, we're going to make it work for elimination. So what that means is if I don't have those coefficients that are going to cancel out right there, I can make that happen by multiplying. We might need to multiply one or both equations. So we might need to multiply one or both equations. So on the bottom down here, we're just going to talk through the multiplying part, and then we're going to do the whole system, multiplying and everything on the next page. This is just going to be the setting it up so they will eliminate. We would like to have one variable that has the same number, but with opposite signs. So I want one to be positive, one to be negative. And we can approach either variable. We get to make the choice. So you don't have to pick the same variable as me. You should still get the same answer. I'm going to show you kind of how I spot the easy way, or which way is going to be easier. Because if we look at our coefficients here, I see a 2 and a 6. And on this one, I see a -5 and a 2. They're all fine numbers, totally fine. I want to see if I can multiply one of these numbers to make the other one. I don't really know a way that I can multiply 2 to make 5 without it being decimally, and I really want to avoid that at all costs. However, if I look at the smaller one here, I do have something I could multiply 2x by to make 6x. What could I multiply 2x by to get 6x? 3. If I multiply this whole equation, both sides, by 3, I will get 6x. However, I would like to have the same number but with opposite signs, so I'm going to multiply everything by a -3. You could also just multiply by 3 and make the bottom one times -1. Totally valid. I'm going to write this out. We're going to do this multiplication. Our -3 times 2x would give us a -6x. Our -3 times -5y is going to give us a +15y. And our -3 times 8 is going to give us a -24. And I'm just going to copy this one down. This one is just our 6x plus 2y equals 1. By multiplying this one equation, this top equation, my iPad of course is frozen right now, we have made it so I now have the same number with opposite signs over here. By multiplying this one equation, I now have a letter that's going to eliminate out. The rest of this might be a hot mess, but I have a set of letters that's going to eliminate out. So if we don't have numbers that match up, we can make them be that way. You can multiply one equation. You can multiply both equations. You might not have to multiply either one, but you can do whatever we need to. We want to wind up with the same number and opposite signs. So on this right-hand one, again, I have choices. I could get my x's to line up, 6x and 8x. I could get 6 and 8 to multiply to the same thing. They both would multiply to be 24. I could do that. I could also just multiply them up to be, 48, because 8 times 6 is 48. That would work. I also have over here my 3y and minus 9y. Well, that one's not too bad, because I could multiply 3 and get 2, 9. So if we look at our smaller values, sometimes we only have to multiply one equation. The smaller value for your letter is going to be the one that kind of helps us figure it out. So I'm going to take this top equation, and I'm going to multiply it. I would like to be able to get to 9y. So what do I need to multiply this top equation by? By 3. It's not always going to be 3, but just both of these happen to be 3's. If I multiply this top equation by 3, I'm going to have my minus 6x times 3, so we get minus 18x. We're going to have our plus 3y times 3, which is going to give us a plus 9y. And our 5 times 3, which is going to give us a 15. Again, this bottom equation, I'm just going to copy over because we should already have the right values. We've got our 8x minus 9y equals 4. So now I have a pair of letters where we have the same number with that opposite sign. When we have the same number with the opposite sign, this letter will cancel out when I add them together in my columns. That's what we need in order to do elimination. Now, we could finish this one out and solve it, but there's not very much space on this page. So we're going to do with solving on the next page. We're going to do the top of page 14. Okay? Questions on this multiplying part before we mush it all together? Because we are given equations like this sometimes, where we have 2x plus 5y equals 1, and 3x minus 4y equals negative 10. This is really not set up nicely for us to solve by graphing. Neither one of these would be easy to graph. And it's not set up very easily for us to get an x equals or a y equals without getting fractions everywhere. We would wind up with fractions everywhere, and that is unpleasant and gross. So when we have stuff that we can't graph and stuff that we can't get to an x or a y equals, that's when we're going to use our elimination. So we get to pick which letter we're going to eliminate out. We can use our x's or we can use our y's. Neither one of these is set up beautifully for elimination. I have a 2x and a 3x. I have a 5y and a minus 4y. So neither one of these is already set up for it, so we're going to have to do at least a little bit of multiplying. When we're going to have to multiply an equation, we get to pick which letter we're going to go for. Which letter do we want to eliminate out, the x's or the y's? There's not a wrong answer here. Y's. Let's look at our y's. So if I want these two pieces to wind up with the same number, but the opposite sign, we want to think of a number that has 5 and 4 both as a factor of it. So what number is divisible by 5 that is also divisible by 4? Other way to think about it, what's 5 times 4? 20. If I want my y's to be 20s, so we want to have 20 y's. That's our goal, trying to get there. I know that 20 is a multiple of 5, and I know that 20 is a multiple of 4. So I want these to be 20s. What do I need to multiply this equation by to make it wind up with a 20 on my y? 5y times what is going to give me a 20? 4. On the bottom equation, our 4y times what would give me a 20? 5. So I'm going to multiply the top equation by 4 and the bottom equation by 5. So I'm going to have to multiply both on this one. So when I multiply that top equation by 4, we're going to have our 2x times 4, so that's going to give me an 8x. I'm going to have my 5y times 4, so we've got 20y. And that's going to equal our 1 times 4, which is 4. So multiplying all the pieces. I'm going to do the same thing with the bottom equation, but this time I'm going to go times 5. So we're going to have our 3x times 5, giving us a 15x. We're going to have our minus 4y times 5 to get minus 20y. And that's going to equal our 5 times our minus 10, which is a minus 50. Questions on that part of it? We're going to finish the whole thing out, get all the way to a solution. Oh, sorry, just scooting this over a little bit because it was right on the edge. Because once we're here and I have my same number with the opposite sign, that's when we're ready to add these together. Old school columns. So when we add together our 8x plus our 15x, what is 8x plus 15x? 23x. Then we've got our 20y plus negative 20y. Yeah, it cancels out. We get our 0 y's. That is not the right pen I wanted. We get 0 y's. That's, I have 20 yams and I give away 20 yams. And then we have 4 plus negative 50, which is going to be a negative 46. So we got our y's to eliminate out. Hello, screen. Thank you. We got our y's to eliminate out by doing some multiplying. We don't typically write that 0 when we have something times 0. So this is the exact same thing as if we had 23x equals minus 46. So if we want to know what x is, we would need to divide both sides by this 23. And this is something we would want to probably put in a calculator. You can absolutely try and do it by hand. It doesn't come out gross. Negative 46 divided by 23 is what? Negative 2. So we know the x of our answer is going to be a negative 2. So my ordered pair, when we get to that point, is going to have negative 2. We just don't know what the y is yet. We got to figure out what that piece is. When we are looking to figure out our y, I'm going to delete some of these arrows. I can use this equation. I could use this equation. I could use this equation. I could use this equation. Anything above this line where we added things in, I can use any of these options. Deriver's choice. It makes genuinely no difference. They will give you the exact same answer. So I'm going to go ahead and use the top one because it's got the smallest numbers. But if you use a different one, it's totally fine. You should get the exact same answer. What we're going to do is we're going to take our 2x plus 5y equals 1. And we're going to substitute in when x is negative 2. So we're going to look at our 2 times negative 2 plus 5y equals 1. So there's a lot of pieces in these. just about keeping ourselves organized. So our 2 times negative 2, we can simplify that. It's going to give us a negative 4 plus 5y equals 1. Then if I add 4 to both sides, we get our 5y equals 5. And what does y equal? 1. Because we would then divide both sides by 5. So if our y equals 1, that means we know the rest of our ordered pair. These 2 lines would cross at negative 2, 1. So more often than not, we're going to wind up with stuff that we don't have to do super tons of multiplying on. We'll get stuff like this where we're multiplying one equation, or we don't have to multiply, or stuff where we only have to multiply one equation, kind of like these ones were. We could keep going and solve things like this. We can still wind up with our no solution or our infinite solutions here. It's just like when we had it with substitution. If we get something that's true, like 0 equals 0, that's when we have infinitely many. If we get something false, like 2 equals 7, no solution. So we still have those same pieces. All those things are going to be very much the same. And I'm actually going to stop us right there, just because I don't want us to try and sprint through another one. That is what the bottom half of the homework I gave you guys yesterday is about. That homework 5. So the bottom half of those are elimination. I would recommend starting with number 10. That's, I think, the easiest one. Okay, so if you're looking at the elimination ones, I recommend starting with number 10 and then doing the others, just because 10's the easiest. I don't know why that makes it last on the list, but it's there. And so I'm going to pass out some of the homework. If you guys got questions on stuff, now's a great time to ask it. We got about 5 minutes left.